Are we rolling?
Yes.
Okay, hello and welcome everyone. I've got the gentleman with me today and we're going to do the finding the, what were we doing? Faraday constant.
Yes.
So this is the setup we're going to use. It's in your textbook, you can find it. So I'm here with the team and we're ready to get started. So Gene and his group, Gene, show them the electrode. Okay, Gene has got 2 electrodes, an anode and a cathode, and they're going to go and clean them very well with soapy water and Scotch-Brite, and then we're going to clean them and dry them with methyl ethyl ketone. So Gene and his team is going to do that. Mark, on the other hand, Mark, show them what you got.
You got copper sulfate here.
So Mark's job with his team is to make 250 milliliters in this standard flask of 1 molar copper sulfate solution. And how many grams does that win? 200 divided by 4.
62.4225.
Okay, 62.42. All right, take it to that balance and then see how much you've got. That's a technical chemistry term. Right, put that on and see how much that is. Okay, more.
It looks like blue raspberry.
Sorry?
It looks so flavorful, but I'll probably die if I take a bite of that.
Yeah, perfect.
I'll tape everything.
Get it nice and
Okay, that's a bit too much, so we take a bit out.
yeah. And then give it a good rinse and then dry and then 62, perfect. Okay, that's perfect.
Damn. Yeah.
Okay, so dissolve as much of that in there as you can in a little bit of water. And then that gets transferred in here. But I'll show you how to do that at the time. So a little bit of water in there and then scratchy it up with the... Are they all clean and drying? Yes. Excellent. Okay, so it doesn't matter how much, just not too much.
Does it stir?
Not yet, just let them pour it in. Bit more, bit more, bit more. Keep going. Keep going, keep going, keep going, keep going, keep going. Stop. Perfect. Okay, and then we want to dissolve as much of that copper sulfate as we can.
Blue Hawaii.
How do you know about Blue Hawaii? I got it on video.
No, it's the flavor for salt, like drink.
Yeah.
Italian soda.
I thought it was a cocktail.
Oh really?
Well, yeah. Same.
Oh yeah.
How do you know it's a cocktail? Anyway, Gene, can you give me a little dinky beaker, the little small one?
Oh, I think it's just a drill.
And let's get a dropper. We need to get the bottom of the meniscus on that line. Okay? So the water will curve like that, or the solution will curve like that. We want it on the line. So I'll demonstrate first time how we do this. Can I have the funnel? Yes, that's it. Okay. So we put the funnel in the flask. The flask, it's got a little bit of water in it, but it's distilled water. It's been rinsed out. Okay? Take the solution. No, I need that as well. Everything here has to go in there. So what I'm going to do is holding the stirring rod in one hand. Okay, all that blue stuff on the stirring rod, I still want that. So I'm going to run this down the stirring rod. Okay? So I'm going to run all the water and you see hardly any of it's been dissolved. So we need to go back in there and we need to run that in, get all the stuff down from the sides and keep on dissolving. Okay? On you go. In the meantime, I'm just going to run a little bit around here. I don't want to go any more because I've got probably 50 mils. This is only 250. If I go past 250, I have to do it again.
He's sick.
Yeah.
Not 6.
He says he's got sore throat, it's like he's eating needles. I said, how do you know? Have you eaten needles before? Probably kissing too many girls.
That's going in. That's going in.
Has that gone in? Did you get that? Did you get that, Mark? I said.
That's going in.
In the M6, in the M5 chemistry class, things we're not allowed to say that makes them, they all snigger when I say it. hold, suck. So when they were doing titration, if I could say with the burette, the pipette filler, suck it up. Keep sucking, keep sucking. Okay, see how I'm doing this? I'm holding this, there is glass rod at the bottom, then I've got more control. You're not in the garden brushing the leaves, Win. You don't need a big long. Okay, so now what I want you to do, I want you to pour it in the way I demonstrated. So get that, that's it, and then pour it down the funnel. Okay, pouring it down the funnel keeps it from splashing everywhere. Put that in there.
How many times are we gonna do this?
Until it's on.
I should have done it yesterday. It'll probably be 40 minutes doing this.
How much?
Not too much. Bit more, bit more, bit more, bit more. It's not very soluble copper sulfate.
Wait, so Aki's also gone? Or
Where is Aki anyway?
Everyone's also gone.
what?
Yeah.
Maybe Aki's going to get the vaccine.
That's also going in?
Everything is going in.
That's why I don't cut.
Right, this time when, what we're going to do is we're going to pour everything in, okay? So what you were doing before, do it the way you were before.
Now?
Yeah. Pour it down the rod. Okay, and I'm going to get all the solid in. So are you watching what I'm going to do here? Okay, keep the rod there. I'm going to get all that in there. Okay. It does look like slush puppy.
Slush puppy.
That's what it was called.
Oh.
Right, now you can see there's still stuff on the glass. If I was doing a proper analysis, I want that. So I rinse the beaker. Notice the skills.
Or like that.
This is his skills.
Okay, I rinse the beaker a number of times. Now this is why we don't put too much water in, because we can only go to that line. We go over, we have to start again.
No,
Right? So I can see a little bit there. Okay, so that's clean. Okay, now I'm going to clean Win's rod. Win, stop moving your rod in and out. Take that out, that's clean.
Okay.
Okay.
What was that motion, bro?
This is gonna be a legendary clip.
How with it?
Don't you dare put it on YouTube. Alright, that's clean. Then the last thing we do is we fill this, and we go to a little bit below the line. Don't go over the line. What happens when we go over the line? We do it again. Okay? Okay. So what I'm going to do is I'm going to go to this small beaker, and Mr. Win's going to do it. So just empty in the beaker, Win, until it gets to about a centimetre below the line. No, just use the beaker. Right? Keep going, keep going, keep going. That's it. Okay, so now we need some more water.
Exactly, bro. Exactly.
Okay.
It's...
Actually, Win, let me stick the funnel in for you. Alright, now fire it in to where my finger is. Whoa, whoa, whoa.
Hey.
Go too far, you do it again. Alright, at this stage, you can see, look, it's not mixed. It's transparent, clear, and it's all wavy at the bottom. So before I tip it up, notice how I'm holding it. Hand around there, thumb on top. You don't put your thumb on top, it pours all over the floor. And we've still got a lot to dissolve. Okay, so I'm gonna run it through. Now, if I was doing this for real, I wouldn't put any solid in here, because if you've got solids in there, you could lose a bit. When you take the stopper out, there might be a bit stuck to the stopper. And what's interesting, feel, it's cool. Why is it cool?
Oh, really?
Because it's taking energy away to dissolve. Feel it.
Feel.
Oh.
No, it's endo because remember, you see how much it's dissolved?
Quite a bit.
Quite a bit. Okay, and the more I do it, the cooler it's going to get. Because when it's breaking down that lattice, it needs to take energy from its surroundings. I was putting urea on my grass the other day, not that Mark's grass, on my lawn garden grass.
What did I do?
And I was dissolving it, I weighed it out and I was dissolving it in water and I dissolved it just in a little bit. And man, it got so cold. I thought it was going to freeze the water.
That's looking mighty drinkable right now.
Okay, so now Mr. Win is going to top it up to the line using the drop-in pipette.
A lot of pressure here.
Yeah, don't feel pressured, Win.
Why is it focusing on Win's face?
Smart camera.
All right, now I can't really see where the line is because of all this foam. Okay, so a bit more, Win.
It's like beer, just drink it.
Unfortunately, a teacher in Scotland was doing this experiment some years ago. Not this experiment, but an experiment with copper sulfate. I've told you this before. A bit more. Put some water in the pipette, Win. Oh, that's it. Just put it in drip by drip. Yeah? 1, 2, 3, 4. Alright, that'll do it. I can't really see the line properly.
Good enough.
It's good enough for what we need. Okay? Thumb on, like I showed you, upside down.
Ready?
Grip it. Not like that. You're not a bartender there, Gene. That's it. Okay, I would go this way. That's it. Okay. Let's get started.
Let's get started.
Okay, at the back. Let's get that glassware out of the way. Mark, get in here. Okay. So we're going to clean them first. So just get another tissue.
Me.
Hey, can you do it? Yeah.
Okay. So simply, bit of this on there. Now it's not chloroform. We're not going to murder people. Don't do that. It probably would knock you out. Okay? Try not to touch it with your fingers.
With your feet.
If you get greasy fingerprints on, guess what? We do it.
Oh my god.
We do it again. What's wrong? What's wrong with you? Saying you never smelt methyl ethyl ketone in the morning.
In the morning? Why would I wake up to that?
Okay, you can hold it at the sides, remember, Gene? We want it nice and dry, so this cloth, what's it called, tissue.
What does it smell like, marker?
Yeah, this is a common solvent in things like that.
เคยเห็นนี่ปะลูกโป่งวิทยาศาสตร์อะ
Wait,
sorry English
okay. I'm trying not to get my fingerprints on it, so I'm kind of holding it with the cloth and then maneuvering it around. Where is he? Okay, you can finish it.
Finish it off.
No, is that the wet one? Don't use that one. Okay, use that one.
เอ้ยเช็ดดิอย่าจะจับ
Do we need to tear the tissue?
Tissue.
You could do that. Would be a good idea. Put the tissue on, tear it, but it doesn't matter as long as the balance is clean.
I think it's not.
Try to get when you're weighing.
4.3 about.
Okay, when you're weighing, try to get that in the middle.
No, it's exactly the same.
ไม่อ๋อ
Now it's going
เอ
down.
อ
4.3.
I think it's way behind.
Huh? Oh, okay.
That's way the end.
Okay.
Alright.
Next.
Damn. Oh. อ่ะเขียน
What is that clean?
อ่ะ
4.45. 6. 5,
เขียน
4,
เขียนเขียนแบบ
3, 4,
If you don't
5,
move,
4.
if you don't move, it's better. See, that's the air conditioner.
So
4.43, that'll do.
Alright. Entertaining.
I'm just emptying this bottle. What did you call this bottle in Thai?
Quart. I mean, well, like.
I remember years ago I was told that this was called pork corn or something like that.
Huh?
Pork corn, like a person.
Quart con.
Did you ever hear that?
No.
Con, I think con meaning like to mix.
Oh, to mix, yeah.
Ah, good man. Right, let's go. Bring them, big cells.
Bring yourself.
Part 2 of the experiment. Which one is the anode and which one is the cathode? How's that looking? It's a lovely colour now, eh?
Oh my. That's not solid.
So which one
It's
do you
a
want to
little
be
bit.
positive? The bigger one or the smaller one?
They're pretty average to me.
Okay? So let's get set up. So this is plugged in. Okay?
Alright, Poohkao, your turn to be cameraman. And please.
Someone in a positive
It's
terminal.
like that, okay?
No, other way around. Okay, negative terminal. Okay, turn the power on. Let's have a look what we're getting. It's set for 2 volts. Okay, I'm going to turn it up a little bit. I'm going to maybe set it to 6 volts perhaps. Okay, so remember how this works. There we go, 6 volts. Okay, so this is, when I turn this on, it's all ready to go. It's at 6 volts. We're not drawing any current because it's an open circuit. Okay? The maximum current we're going to get is 3 amps, but we won't get that. Right, have you decided which one is the anode and cathode? Yes, matters crucially.
The 4.3 one would be.
Okay, so get a pen and write anode. And where have we got? Oh, hold on a second. Hold on. Okay. So the anode is positive or negative? Positive, right? So that's
Everyone,
the anode.
everyone looked at the wall just now.
And the cathode, negative. Okay? So let's make this one the cathode because I had the blue pen in my hands. Okay, and let's make this one the anode. Now, this is not very good scientific practice. We should write it down in our lab notebook, not on a bit of tissue or on the sleeve of your lab coat. All right, now carefully what I want you to do, okay, that's it. Slide, so I'll demonstrate with this one, okay? Slide that in there so that a little bit can be clipped on, okay? Actually, that'll make it a bit easier. There you go, you guys do that. Okay? Kia,
อันนี้คืออะไร
can you get me a 250 cm cube beaker? So the third size beaker, not the smallest or the next smallest. Yes, good man.
yes
Doesn't
Okay.
go deeper.
No, let me see. Possibly down a little bit. Okay, maybe a little bit more. About a centimetre above the thing. Excellent. Okay, Mr. Wynn,
Yeah, my bag.
fill this. Probably to about
What happened?
250.
250. Oh, bro. Pouring that thing makes it look even better.
It sounds good too. Now be careful, Wynn, because when you tip that up, it's going to be a big sploosh.
Wait, 200 or
Looks
250?
excellent. Let's go 250.
Yeah, the more.
Okay, now you can see there's a little bit left in the bottle. But that's fine.
I mean, we
Okay,
already went
that
over, so.
in the sink, give it a quick rinse. Okay, so let's get set up over here. So gentlemen, you need to bring your electrodes set up. It's your lab, it's not my lab. Be careful. This is why we don't use chairs in the lab. Okay, immerse in the liquid. Try not to let it touch the side, like the anodes, the electrodes. Okay, they're not touching the side, are they okay?
Yeah, I think we can move it a bit then. Yeah. Because the cathode, so yeah.
Is that better?
That's
Is that one
that
touching
is.
the side?
No, that's good.
Okay, so now we connect black wire to the negative. That's it.
The black is negative.
Oh. And red to positive.
That's going like that. Oh.
Oh. Try to balance. Let's see if we can put it both like this. Maybe that'll balance it a bit better.
No.
Stuck here?
Oh, yeah.
No, we don't need stuff here. I think that should be. I think that should be fine.
Yeah.
Okay, power on. No, power's on. The power's on there. On at the front. Okay. On off. Yes. Whoa, 2 amps.
Damn.
Okay, 2 amps is too much
Oh.
because I don't want to heat the water.
Do it again.
Okay, can someone?
Wait, we could control the current?
Yeah.
The whole time.
Okay, ready?
Oh, hang on.
เฮ้ยรีใช่ไหมรี
Ready?
Yep.
Go.
What shit?
So this is, now it's in constant current mode. Because that's where I wanted it. Okay, so now we leave it for 45 minutes.
Huh? 45?
Yeah.
So I must do like this for 45?
No, you can turn it off and then we'll do the end of it.
คัน
I cut. The desktop.
Oh, okay, so we're going with that, are we? Okay, time up. Off. Okay, so power's off. Can we disconnect the leads, please? It's alright, power's off, no problem. Nothing's going to bite you. Now let's lift this out. Is there any change?
That's a big change.
Damn. They changed teams.
They did, they swapped sides. So I think we can see it definitely looks like the cathode has had something deposited on it. And if we look at the anode, does that not look thin and...
The other looks dissolved or like melted.
Yeah, that's what I'd be expecting.
The cathode looks so much smoother. I mean, the color wise.
This one is gain, right?
This one should have gained weight, this one should have lost weight. So the thing is, we've got to be careful because I can't, if I scrub this, I might take some of that off. And if I scrub, this one should be all right. That's why we generally weigh this one. Okay, so let's take this one out. Do we have some tissue? So this is the anode. Okay, so give that a quick dry and then go and weigh it. And let's leave this one to sort of drip dry by itself.
Can I?
Yeah, sure, you can dry it like that. I don't think it'll be a problem. Just try and keep your fingers off it. Although it's not as important now. Let's hope it's not gonna.
Oh.
Oh, very smart.
Did you get that?
Okay, so at first it's what?
4.3.
4.3? Oh, look!
Oh.
3.8! So it did went down.
3.84. Okay, write that down.
Write that down!
Like 8 4?
Yeah. Excellent. Okay.
This is the new notebook.
So let's have a look here. So 0.16. So it's nearly lost half a gram. So if we get the other one,
You should gain half a gram.
well, it's not because we had stuff that didn't come off that got stuck on here. 4.43. So we should be expecting about.
It's enough, right?
Yeah, we could probably just. We would expect about 4 point.
4.6.
4 point, yeah, 4.4, 4.8, no, nearly 4.9. See what we get.
Now. Let him cook. I said, let him cook.
Okay, let's go and do the calculations.
400.
4.90,
Over 400.
or 91 it was, wasn't it? 91.
Done one.
Okie dokie. 45 times 60. 27, yeah, you're right. 27,000? No, 2,700?
No, just 278. Oh yeah, 100. So that's 1,000. 2,700.
2,700. Is that right?
One again.
45 times 60.
45 times 60.
2,700. Yeah.
Okay, so the time in seconds is 2,700. What was our current?
500.
0.5
Okay,
amp.
500.
sorry, current over amps.
0.50.
0.50. I don't need that because I've got that there. Okay, so let's find charge. Q equals
90.
IT, which is 2,700. 0.5 amps times 2,700 seconds, which is 1,350
Yes.
Yes.
coulombs. Okay,
Wow.
so that's the first bit done. So the mass lost. Okay, what was the mass lost? What was the initial mass, Gene? 4.30
Yes.
minus
3.84.
3.84, which is 0.46 grams. Okay? Now, we need to think about what we're... At this stage, we could use the Faraday to find Na, or we could use Na to find the Faraday. So the first thing I'm going to do is number of moles. So let's just call it N copper. Okay? So N copper is going to be the mass in grams divided by AR copper. Isn't it? 0.46 grams divided by, what's copper? 64.5 or 65.4? Can anyone Google 65.4 or 64.5?
On 64.
Point
63.5.
63.5. Here. Okay? 63.5. Someone do that for me?
7.244. To 10 to the power minus 3.
Okay, so that's how many moles. Okay? Now let's have a think about this. What's our reaction? Cu2 plus 2 electrons goes to Cu solid. Okay? So the number of electrons here is going to be twice this, isn't it? So Ne for the number of electrons is going to be 2 times 7.24 times 10 to the minus 3. Okay? Now, so I have Ne electrons, so here equals 1350 coulombs. Yeah? 6.02 times 10 to the 23 electrons equals X. Yeah? So how can I find X?
6.02 times 6.02 10 to the power 23 times NE. Wait, divided by NE.
So let's evaluate what that is. Let's do this one. What's this one? 142 times 10 to the minus 2, no? 1.42 times 10 to the minus 2? 1.4. 1.448 times 10 to the minus 2. Is that how you win?
Yeah.
So this is 1.44 times 10 to the minus 2. So now if I do this is going to be much bigger than that. So it's going to be this 6.02 times 10 to the 23. Yeah? Divided by
1, 3.
no, that can't be right. No, what we're talking about? It's 1. It's 1 mole.
Oh.
Okay? So it's going to be, X is going to be, I'm sure one of you said this, 1350 coulombs divided by 1.44 times 10 to the minus 2 equals 93,750. Not bad, eh? What was the right value? 96,500. Error? What's the error? So 96,500 minus this divided by 96,500. That 96,500 minus that divided by 96,500 times 100%.
Then divide 9, 6.
500, yep. Times 100.
2.8.
2.8%, I'll take that. I mean, you know, if we had probably done an accurate timing to the second, rather than, you know, the last bit. But I think it's, you know, 2.8%, that's not a bad result, is it? Yeah? I mean, I'd be quite happy with that. Normally, when you do this experiment, you tend to get a bit more. You tend to get round about 100,000. But either way, it's not too bad. Well, we'll have to say goodbye. So everyone,